Hello, and welcome to Spaceflight Histories, a channel dedicated to telling the history of space exploration. My name is Erin, and today we're looking at the Soviet Lunokhod program, a pair of robotic rovers that landed on and explored the moon in the early 1970s. The name Lunokhod is Russian for moonwalker, and the program operated concurrently with the Zond and Luna programs. The Zond series consisted of 6 uncrewed missions that circled the moon and returned to Earth, or at least flew past the moon, between July 1965 and October 1970. Zond 5, the first successful Soviet circumlunar flight, also carried the first living creatures to the moon, most notably a pair of steppe tortoises. The manned Zond spacecraft would have slingshotted 2 cosmonauts around the moon, but not placed them into lunar orbit. I think it goes without saying there were no manned flights of Zond. Luna, mistakenly called Lunik in the West, was a long-running program that consisted of lunar robotic spacecraft missions, flybys, orbiters, and soft landings, and despite the Soviets never sending a human to the moon, they did make the first flyby, the first soft landing, take the first photographs of the moon's far side, thanks to captured American film, and deploy the first lunar rover. The Soviet manned lunar plans are a lot to get into, but here's what's important to this video. The Lunokhod rovers were initially designed to support the manned lunar landings of the N1-L3 program. The N1 rocket was the Soviet equivalent of the American Saturn V rocket, a super heavy lift launch vehicle intended to carry the L3 expeditionary complex. The L3 system included the Block G and Block D upper stages, the 4th and 5th stages of the N1 rocket, the Luni Korabl, or LK, lunar lander, and the Luni Orbitalny Korabl, or LOK, lunar orbital spacecraft, a modified Soyuz 7K OK spacecraft, the first generation of the now nearly 60-year-old Soyuz. The LOK would have carried a crew of 2 cosmonauts, while the LK would have landed only 1. In original plans, 2 Lunokhod rovers would be sent to the moon to survey the landing site on board an unmanned LK lander a few weeks before the cosmonaut would arrive in his own. First LK would serve as a rescue craft should the manned LK fail, as they would be within walking distance of each other. The Lunokhod rovers were designed under the direction of Georgy Babakin, the chief designer at the Lavochkin Design Bureau, a Soviet and now Russian aerospace company and major participant in Russia's space program. The metal chassis were designed by Aleksandr Kermudjian. The rovers were 4.5 feet high, 5 feet and 7 inches long, and 4 feet and 11 inches wide. The tub-like compartment sat on 8 independently powered wheels that had only 2 operating speeds, approximately 1 and 2 kilometers an hour, or 0.6 and 1.2 miles an hour. On the inside of the tub's lid, which covered the instrument bay, was a solar array that charged the rover's batteries as they drove across the lunar surface during the day. At night, the lid closed and they went into hibernation mode, the polonium-210 radioisotope heater unit keeping them warm. The rovers were equipped with a cone-shaped antenna, a helical antenna, 4 TV cameras, and special devices to take samples of lunar regolith, as well as an X-ray spectrometer, an X-ray telescope, a cosmic ray detector, and a laser device. The Lunokhods were transported to the surface by Luna spacecraft and were launched by the Proton K Block D launch vehicle, a 4-stage launch vehicle originally designed to launch manned circumlunar spacecraft. It actually launched unmanned lunar and Martian spacecraft, which had varying degrees of success. The Lunokhod rovers were controlled from NIP-10, a satellite tracking and communication center located in the formerly closed town Simferopol 28 in Crimea, now the village of Shkolnya. Closed towns or cities are areas with restrictions on residency or travel. They were more common in the Soviet Union during the Cold War and were often near sensitive military and scientific facilities, such as space and nuclear research sites, and near borders. In the United States, towns that housed Manhattan Project personnel were kept secret, and settlements around the world involved in weapons testing and virological research are restricted. Anyway, NIP-10 controlled the deep space missions of the Luna, Venera, and Mars programs. A lunodrome, or moondrome, was built to evaluate the performance of and solve issues with the Lunokhod rover's framework and train engineers to drive it. The lunodrome had an area of 394 feet by 230 feet and included 54 craters and around 160 rocks of various sizes. Lunokhod was controlled by two 5-man crews of engineers from the Soviet Missile Defense Corps. One man would drive the rover using a joystick, one would serve as navigator, one would operate the radio antenna, the flight engineer would monitor its systems, and the fifth would act as a commander, overseeing Lunokhod's operations. The teams alternated controlling the little rovers every 2 hours. According to 2 articles about Shkolno's role in space, published in the Rural Worker of Crimea newsletter in 2023, one of the designers of the rover chassis, Felix Spock, wrote a short anthem for the Lunokhod crew. According to Smithsonian Magazine, Lunokhod could drive in reverse and make turns the same way tanks do, by slowing down one side of its wheels relative to the other. Since the rover's cameras sent single frames to Earth every 7 to 20 seconds and not a continuous stream, and because radio signals took 3 seconds to make the trip from Earth to the Moon and back, driving Lunokhod was tedious, and probably kind of like playing Minecraft with really bad lagging. In place of a continuous stream was a sort of slideshow with each picture visible for up to 20 seconds, during which Lunokhod could quote-unquote blindly travel up to 26 feet. The Crimean newspaper and Smithsonian Magazine articles are in the description if you'd like to read more about the controllers and their work. Their names did not appear in print until 1993, not surprising given the heavy shroud of secrecy surrounding the Soviet space program. The first Lunokhod rover launched on February 19, 1969, but was lost when its Proton rocket exploded 40 seconds after launch. Like other vehicle failures of the era, this loss was not made public until years later, and resulted in polonium-210, the Lunokhod's radioactive heat source, being spread over a large area of Russia. Lunokhod 1, the first successful Lunokhod rover, launched on November 10, 1970, and was the first roving, remote-controlled robotic vehicle to land on another celestial body. Luna 17 carried and landed the rover on the Moon. The pair entered lunar orbit on November 15th and soft-landed in Mare Imbrium, or the Sea of Rains, on the 17th. Luna had dual ramps so the rover could easily roll down to the surface. Lunokhod 1 operated for 322 days and traveled 6.5 miles, taking more than 20,000 television images and 206 high-resolution panoramas, and performing 25 lunar regolith analyses. The rover ceased operations on October 4, 1971, the 14th anniversary of the launch of Sputnik. Its final resting place on the surface was a mystery for nearly 30 years, until 2010, when Russian scientists found Lunokhod 1 and Luna 17 in an image taken by the NASA Lunar Reconnaissance Orbiter. Lunokhod 2 launched with Luna 21 on January 8, 1973. The two entered lunar orbit on January 12th before touching down in the Le Monnier crater at the Sea of Serenities, or Mare Serenitatis, eastern edge on the 15th. Lunokhod 2 was more advanced than its predecessor, and some of its primary objectives included surface photography, studying light levels to determine the practicality of astronomical observations from the Moon, and studying the mechanical properties of lunar regolith. Lunokhod 2 took pictures of Luna 21 and their landing site after rolling down the lander's ramp to the surface. On May 9th, Lunokhod was accidentally driven into a crater, and while its controllers were trying to maneuver it out, its open lid touched the crater wall. Regolith fell on top of its solar cells. Lunokhod re-emerged an hour later and continued on its journey, but when lunar night came and it closed its lid, it dumped regolith onto its radiator. The rover was no longer able to cool itself, and its internal temperature exceeded 150 degrees Fahrenheit. 2 days later, on May 11th, contact with Lunokhod 2 was lost. The rover operated for just over 4 months and covered 24 miles, including hills and rills, or the long, narrow depressions on the lunar surface that look like channels. This number varied over the decades. Initially, Soviet scientists estimated Lunokhod 2 traveled 23 miles based on its wheel rotations. In March 2012, the rover and Luna 21 were spotted by the Lunar Reconnaissance Orbiter, and in 2013, Russian scientists revised its mileage to 26 miles. But in 2014, that number was revised again, this time at least partly thanks to discussions with American scientists, to the official 24 miles. Lunokhod 2 took more than 80,000 pictures and 86 panoramas, and program completion was announced on June 4, 1973. The rover held the record for longest distance of surface traveled by a vehicle on an extraterrestrial body until 2014, when it was broken by NASA's Mars rover Opportunity. By the time contact was lost with Lunokhod 2, the Soviet Union had already soft-landed its Mars 3 spacecraft on Mars, though it failed 110 seconds after touchdown, and NASA was developing its Viking Mars lander. The final N-1 rocket was launched and lost in November 1972, and the last manned Apollo mission, Apollo 17, left the lunar surface in December 1972. Lunokhod 3 was planned for 1977 with Luna 25, but did not launch due to lack of funding and available launch vehicles. It is now on display at the NPO Lavochkin Museum in Moscow. After the collapse of the Soviet Union at the end of 1991, the NIP-10 station was transferred to the Ukrainian Space Agency, and the military units that operated there were disbanded in 1998. Over the next few decades, a number of buildings, including the NIP-10's museum, were destroyed, but the large TNA 400 antenna still stands, silently pointing to the cosmos. 2 more Lunokhod rovers were built in the 1980s, not for any sort of space exploration, but to help clean up radioactive debris from the Chernobyl nuclear power plant disaster in April 1986. Some of the remote-controlled bulldozers the cleanup team initially used were too heavy to operate on the partially collapsed reactor building roof. Lunokhod designers were brought out of retirement after more than a decade since the rovers traversed the moon, and 2 weeks later, 2 new rovers called STR-1 were complete. The rovers were a natural choice for nuclear disaster recovery work because they already used nuclear decay as a heat source. They were delivered to Chernobyl on July 15, 1986, and cleaned up about 10% of radioactive debris before succumbing to extremely high radiation levels. More than 50 years later, Lunokhod 1 and Lunokhod 2 remain dormant on the lunar surface. Under Article 8 of the Outer Space Treaty, the framework for all international space law and policy, a state party to the treaty on whose registry an object launched into outer space is carried shall retain jurisdiction and control over such object while in outer space or on a celestial body. This means, for example, the United States still has jurisdiction over the Apollo lunar modules. This also means Russia, and by extension NPO Lavochkin as the manufacturer of the spacecraft, retains control over the Lunokhod spacecraft and their Luna landers. Why am I telling you all this? Because in December 1993, at a Sotheby's auction in New York, the Lavochkin Association sold ownership of Lunokhod 2 and its Luna 21 lander to Richard Garriott, a private astronaut and the son of Skylab and Space Shuttle astronaut Owen Garriott, for $68,500, or just under $153,000 when adjusted for inflation. Richard Garriott amassed his fortune developing video games, but due to vision problems, was not able to follow in his father's footsteps as a NASA astronaut. But then space tourism became a thing in 2001, and in October 2008, Garriott spent 12 days on the International Space Station as a member of Soyuz TMA-13. He became the first second-generation American space traveler and also flew with Sergei Volkov, the first second-generation Russian cosmonaut. Garriott remains to this day the only private citizen to own an object on a celestial body. After Lunokhod 2, the next remote-controlled rover to roam the lunar surface was U-2, a Chinese rover part of the Chang'e 3 mission, which landed in December 2013 and operated until August 2016. The Chinese Chang'e 4 U-22 rover, the Indian Pragyan rover, the Japanese Smart Lander for investigating moon lunar excursion vehicles, and the Chinese Chang'e 6 Jinshan rovers landed on the moon in the past 10 years. The only American lunar rovers were the Apollo lunar roving vehicles driven on the moon by astronauts. Following Lunokhod 2, the next remotely operated rover to land on a celestial body was a little Mars rover named Sojourner as part of the 1997 Mars Pathfinder mission. Though overshadowed by the Apollo lunar landings, and some details of which were kept secret for decades, the Lunokhod rovers, their designers, and their operators were pioneers in their own right. As the first remote-controlled rovers to operate on another celestial body, they laid the groundwork for the current era of roving robotic spacecraft, and though now defunct, serve as tributes to the thousands of individuals who dedicated their lives to exploring Earth's oldest satellite. Thanks for watching, and I hope you learned something new today. I'd also like to give a huge thank you to the 1,500 of y'all who have subscribed so far, and a bigger thank you for sticking around while I've been gone. As always, my sources can be found in my Lunokhod web article linked in the description, and if you want more space history, hit subscribe, and I'll see you next time.